And every now and then I get something a bit peculiar, and they say, analytics, we've been doing that for 25 years, or this is nothing new. So really what I'm going to talk about in the next 30 minutes or so is some of the research that I'm doing as an analyst and a consultant that's describing what's emerging within the analytics space. So a little bit about ARC. So ARC, we like to think that we're a unique research company where our roots start in automation or operational technology. Generally speaking, the people that come to work for ARC, they're all senior people in industry. We've got economists that work for the company. We've got folks that come from pulp and paper, chemicals, pharmaceutical, many different industries. And the other thing about the company is that we're in actually 10 or 11 different regions around the world. So the main office is set up in Boston, Massachusetts, in USA, and we've got presence in Germany, Europe, Canada, France, Japan. So it gives us a different perspective of actually what's happening around the world in terms of best practices, emerging practices, and technologies. And the company came to be in about 1986. They actually got their start doing market studies for things like control valves and distributed control systems and real-time control systems that are running many of the plants today. And now they're very focused on a lot of the IT type technologies that are used in a manufacturing facility. So what I really want to talk about is digital transformation. Oftentimes we use buzzwords like industrial Internet of Things or Industry 4.0. There's many words that are common today amongst our industry. And really what it comes down to is we think that there's a lot of things that are different today than there was yesterday. And ultimately some of it is because computing is getting cheaper and organizations are getting better at deploying technologies, and it's getting easier to get solutions to the market in order to solve different operational or engineering problems. But really, one of the things that we've noticed, and this is the focus for today's meeting, is the process industries have a tough time because they have difficulties understanding where they have operational risk. They have difficulty understanding handover of information on capital projects. They have difficulty assembling the data that's in the many disparate systems that are spread throughout a plant or a facility. So much of this data today exists in process historians or time series databases. So much of this data is not actually used today. It's for short-term purposes, and there are some tools that I'm going to talk about that focus specifically on the time series data. But basically, most of this data is archived and left for some future undefined purpose. We also know that capturing the knowledge of what's in the workers and the people that understand process facilities is really hard to get. And we know that the erosion of the workforce is something that is very real as the baby boomers exit the workforce. So with all of that, there's a new technology that we're seeing called machine learning, and I'm going to explain what machine learning is as it relates to process analytics. And ultimately, I'm going to talk about some of the outcomes that we're seeing across the process industries in terms of how machine learning and analytics technologies can actually help predict what's happening with your process and with assets that are moving your process. So one of the things that we notice about process analytics is if we look at business analytics, it's not, the way we would describe this is not vastly different. So business analytics gives you the ability, and this is where the original BI tools started as tools that were present to help financial departments be better at forecasting. This would be for a supply chain, or it'd be for forecasting projects or forecasting costs. But generally speaking, the emergence of business intelligence and analytics has helped companies answer questions, not just what's happened or what's happening, but think about more of what will happen, when will it happen, and what can I do about it. So these questions have been answered for several years within the business intelligence and business analytics market. But what we're seeing now is that the analytics technologies and tools are those structures and processes are moving closer to the plant. So when you look at this from a plant perspective, in thinking about how to operate, how to properly maintain, now the disciplines that are in a refinery or a chemical plant or a pulp and paper facility, they're asking the same questions, where they've always had the ability to know what's happened, or generally that can be answered very quickly. But some of the other questions about the process, about why is this actually happening, what will happen, when will it happen, and what can I do about it, that's been very difficult to answer when looking at process historian type data. So if I look at the last decade or two of deployment of process information, we've had our usual reports through crystal reporting or some other tool. So it's easy for us to generate these on a shift basis, or on a daily basis, or a weekly or monthly, whatever makes sense. And we walk into facilities and we see dashboards on the screen or the TV, and these generally are really good at displaying key performance indicators or trends, so that you know what's happening when you visit a facility. So in terms of what's happening, enterprise manufacturing intelligence solutions have been good at this, and it does take some work to aggregate information so that you can produce a dashboard or some type of an overview of a facility. But why is this happening? It takes a little bit longer. So at ARC, we've actually divided up the process analytical spectrum into a few different buckets, and we describe the KPIs and the reports as more the descriptive analytics. But when you get into why is it happening, these are what we call diagnostic analytics. And when you start thinking about cross-functional context across different disciplines in a facility, and answering questions about what will happen in the future and when will it happen, this is where we get into what we would say is the predictive analytics market, or even the prescriptive, because ultimately it's one thing to know why something is happening because you've gone and you've looked at the operator logs, or you've looked at the trend tool, you've done an analysis in Excel or something like that. But actually being able to predict the future is something that takes many hours, if not weeks, to figure out. So we see this emergence of machine learning algorithms being applied to process data, which is making it easier for companies to think about when things will happen. And this is from a process perspective, in terms of whether or not there's an anticipation of a change in a batch or a change in a grade, or you may anticipate tower flooding or something else, or have a distillation process in a refinery. But ultimately, what we see happening is the tools, mainly driven by machine learning algorithms and new technologies, the tools are actually getting much better at helping operators and engineers know what they can do about it. So in terms of what are the use cases that we see in the industry, we see process variability. So optimization and advanced process control have been good at this, but we also see an application for predictive analytics to be able to look ahead and see what's happening, so operators or engineers can make changes manually. But companies are justifying this in terms of maintaining production and energy, and avoiding process trips. We see applications for this predictive analytics and process quality, and avoiding reruns and avoiding waste, and making sure there's no customer impact. But we see this also not just about process, but we also see it about asset health and predicting the behavior of assets so that assets are performing as expected to move the process. And ultimately, this is there's huge benefits for operators in being able to predict incidents and avoid unplanned downtime or worker safety. Many of you may have heard of the Abnormal Situation Management Consortium. This is a group that Honeywell does a lot of work with us now. Honeywell is an automation solution provider, but essentially this is a well-known statistic. So the ASM group is they're focused on identifying challenges and factors associated with process operations, and they're looking at things like improvements to the operator interface and safety systems and control systems. But generally speaking, the sources of statistics that they call out are, out of all the incidents impacting the process industries, 42% of those are caused by people, and 36% are caused by equipment, and 22% is caused by the process. And that box is a little bit small there. But when we look at that, we think that there's a little bit more information that can be derived if you study that actually deeper. So we look at it as although ASM statistics would say the process is 22%, we think that the process is actually probably a little bit higher than that, because if you look at equipment and assets, that do they really fail? Are they really responsible for 36% of the process upsets or slowdowns? Or is the asset failing because of what we call process abuse, or operating the asset incorrectly? So we think that if operators and engineers had better ability to predict the process, right, then perhaps maybe the process could actually be lessened, and it could improve process availability. And we think it's also important that, is the 42% accurate for causes of shutdowns or slowdowns, because do we give the operators and engineers the right tools? So we think that machine learning will actually shift some of the statistics in terms of what's happening to cause a plant slowdown or shutdown. So we have a lot of tools today, and I mentioned this in one of the first slides. We talk about this thing called infrastructure. So the primary tool that has been used in a process facility is the ProcessHistorian. What do we know about this? We know that it's a proprietary database, and there's over a dozen different suppliers of ProcessHistorian out there. These are really good at collecting data, and many suppliers of ProcessHistorians have done a fabulous job at making these devices able to talk to many different assets and systems, DCSs and PLCs. So they're really good at collecting data, and they're really good at writing data, but they're not good for things like search. So in terms of finding particular events and correlating this with other information, this is really tough. Many suppliers have done a great job of integrating these with EMI solutions and creating the dashboards, which I spoke about earlier, and certainly standards like OPC have been instrumental in making this easy. But we know that many companies also, they use short-term data, and they apply some of their process analytical tools in this area, but most companies don't make use of archives. We think that they're more rear view looking, and the majority of the work that's done is in Excel. So the Excel is probably got most of the white space here. That is the main tool that most engineers would use to be able to figure out process performance. So what about this thing called machine learning? I just want to talk a little bit about that. What I recommend is, if you're really interested in learning more about machine learning, we have other information available in more studies, but we basically see that this is computer science that's evolving from pattern recognition and computational learning, or else we also call this artificial intelligence. And the goal of this technology is to mimic the human mind behind our behavior. So taking things that are repetitive in nature, taking them away from human, applying algorithms for abstract thinking, and learning from past experience. We also know that machine learning is closely related to data mining and statistics. So basically, artificial intelligence is a method of teaching computers to make predictions about some data. we know that it's using this term big data, which is usually applied in the process space to lots of different data sets and predictive algorithms, and there's lots of machine learning algorithms that are available in open source as well. There's a couple of different types of machine learning that are important for process data. These are both supervised and unsupervised, and basically this will apply a little bit to process data. I'm going to talk about it a little bit in terms of things like looking for patterns, and this is done through both operator input or engineer input, defining this event through process trend, and unsupervised, which is also the use of algorithms to identify this on the behalf of the human. So one of the things that we know for sure is it's hard to get context from operator or engineer. Everybody that's in a process facility has their job, whether you're in environmental or you're in safety or you're in maintenance or operations or engineering. We've all got our own data, we've all got our own frame of reference, but it's very difficult to contextualize that. And the way that it has been done is we tend to take the streaming data and we contextualize that in EMI platforms or other dashboarding type tools, but it's still hard to apply that context, right? So one of the things that we think is also important is getting this context from the operator or engineer or other discipline in a facility and applying this in an area where it makes sense. So you can do that at the dashboard, and I certainly think that there are reasons why you will always use dashboards, but there's also a reason to make this context at the source of the data where it's actually being collected at, and this is at the infrastructure level. There's often there's talk about this new emerging role called the data scientist, and especially in the enterprise space and the Internet of Things, and then as soon as you start talking about big data, enterprise solutions, they'll start to talk about this concept of a data scientist. One of the things that we've noted is a data scientist is not a normal role that's in the process industry. So I'm going to talk about a couple different ways to apply machine learning algorithms, and one is to apply it at the source using a data scientist, the other is at the enterprise level. Data quality, many of you that work with historian tools, you know that data quality is really important in terms of making sure that you understand gaps in data and you've got appropriate data compression rates, and ultimately when you have a trend that's at a certain that has a certain pattern, you can understand that that trend is the way that it is because of maintenance or because of some other factor. So we think that it's going to be really important going forward in industry to make sure we get this context correctly from the operator or engineer at the place where it makes sense. We also know that knowledge capture can't be completed by training alone. And many of the studies that are out there point to 30% of the industrial workforce retiring. So we know that there's a lot of knowledge that's embedded in the minds of the operators and engineers that are operating plants, and this is either through operations that spend time going outside, or the operators that spend time at operating consoles in front of a distributed control system. So the one way of capturing intelligence is to build training programs and modules and learning management systems, and you can also build that into a simulator, both 3D or 2D. So there's certainly lots of reasons why you'll continue to train operators that way, but by taking the tools at the process information or historian level and embedding information at that level is another way that can be a little bit more efficient, and I'll talk about that. So what we're seeing in the market is this emergence of this analytics platform, and there's a couple of different ways that we're seeing it go. One is the next-gen digital cloud platform, and an example of one of these solutions might be the GE Predix example, where you build a data lake, you've got your app enablement, you've got a bolt-on mobile platform, it could have a social. You probably need a data scientist or two in order to make it work, and generally speaking, you've got to start building on an enterprise platform. The other way to do it, which is we're also seeing, is what we call the try and buy type solutions. So the argument for best in breed versus ERP, which was predominant for the last few decades, is still alive and well, even in the analytics space. So the other side of analytics solutions is we're seeing an emergence of these try and buy solutions that bolt on to existing historian infrastructure and re-index the data, so to speak, because the databases are hard to get at and proprietary. And these projects generally they compete with the full stack solutions or long projects. So we're also seeing very specific analytic solutions as opposed to generic ones. So there's a couple of different ways that we think this market's going to move forward. And one could be the small bolt-on on-premise solution, or I guess it could be cloud as well, or the next gen IoT type platform. So we also know that, getting back to data, getting holistic insights is difficult to get. We know that there's many different systems of record to try and tap into, whether it be operator logs or the engineer that's responsible for quality of a particular batch is probably doing a workup of a scenario in Excel, and that's hard to share that data. We know that there's information in the operating rounds and the many different databases. So generally, when it comes to answering analytics types questions, for example, what's happening, why is it happening, when will it happen, and what will I do about it, answering those questions today takes weeks. So generally speaking, the rule of thumb that we hear is it's about 10% of the time is generating the report, and 90% of the time it's just gathering the data from all the different sources. Back to business intelligence and dashboards, these are all IT heavy. So the challenge is for manufacturing operations is they tend to not have IT experts on staff, or at least they have IT experts, but they're more infrastructure focused and they're not available to support these types of applications. Offline spreadsheets, these things are everywhere. So Excel is probably one of the biggest enemies and friends in the process industries because, one, it's easy to get going for operators to take process information data back to Excel, but it's also really hard to share, use this for other applications, and it takes too long to make the decisions. From a maintenance perspective, this is probably kind of important because we think machine learning and analytics technologies applies to process and to physical assets. And from predicting the process is one side, but predicting asset failures is usually a different discipline. So on the top here in the blue boxes, the old way to do this is you take a single variable like a vibration or another vibration or XY plot, and you're looking at the streaming data, which says this is the condition of this machine, and you generate a workflow. Maybe you've got an automatic work request. You alert the engineer or operator, and what the predominant outcome of this is a high degree of false positive, or basically operators tend to lack. They don't trust the system, and it also generates a reactive maintenance philosophy. So that's another way to describe this would be condition-based monitoring. So the emergence of analytics for machines, this is where we think is different is because machine learning is able to look at multiple variables, and you're not just looking at the streaming data of a particular point off an asset. In this case, the one on the screen, I've got an axial compressor or a turbine, part of a jet engine, but they're also looking at the time series history as well. When you apply machine learning or we also call this precise pattern recognition. When you apply that using unsupervised and or supervised learning, what we see is also same workflows, same work request can be in place, and same alerts to the operator and engineer, but we see a significant reduction in the false positives. So what that tends to do is it builds more trust in the system. You've got more days notice of failure of process or of asset, and it lends itself to more of a predictive maintenance philosophy. Because we're an analyst firm, we like to do a lot of surveys and we like to talk to a lot of customers. This is a recent research initiative we did on the industrial Internet of Things. Another one of these buzzwords on disruptive technologies. But in this case, we asked our clients about the business drivers for analytics and outcomes they were looking to have solved. And the number one things that they were looking for is ultimately they want better process performance, and they want to reduce asset downtime. So in terms of use case of process analytics, this is probably the number one and the number two. Another reason for what's driving this is the maintenance perspective. So we find that especially with the oil and gas industries, oil prices the way that they are today, companies are forced to make concessions and figure out better ways to operate and maintain and reduce cost. So more and more companies are looking for ways to try and move away from corrective or break-fix maintenance and away from preventative or scheduled, which both of these types of maintenance approaches are costly, to more predictive. So from the full spectrum of the types of things that you might do or the approaches you might use to maintain, predictive and prescriptive we see as the lowest cost, the fewest amount of false positives, and the most trust by the operator. So companies that are starting to leverage these new tools for predictive analytics or prescriptive analytics are starting to reduce cost. Having said that, in 2015, still the number one method of approaching maintenance is to use preventative maintenance techniques or corrective. This is some study data where we've looked at a UAL study from 1968. The U.S. Navy did one in 1982, and other companies as early as 2001. There's lots of studies out there that look at age-related failures and random failures. And the interesting thing about all of this data is it shows that random failures are only 82%. But what this study doesn't address is it doesn't address how the assets are actually operated, and I think that's one of the biggest problems. And even mean time before failure of assets, it works really well for the test bench, but it doesn't work in process operations. So one of the things that we're seeing for predictive and prescriptive analytics is the ability to actually add accuracy to MTP or mean time before failures for a facility or a plant. And back to, I'm using a pump example for an asset. We see the convergence of both process and discrete from the perspective of the physical asset, and oftentimes because we give our reliability technicians or our operators tools that are fit for purpose for them, they don't often get an opportunity to look outside of their particular assets. So you might have a maintenance person that he sees the temperature of the windings of the motor, he sees the thrust, the vibration, maybe they might see the discharge pressure off of a piece of pump, and they try and do reliability and predict the health of that pump to support a given process. But the reliability people aren't looking at what's happening upstream or downstream because that's outside of their discipline. And the same goes for an operator, where an operator who's operating that pump in terms of its on-off and speed to control flow, they see the process and they don't see the asset. So one of the things about predictive analytics or prescriptive analytics is these tools are able to pull the data from both machine and process in a way that provides the context they need to predict the failures. And the other thing that we would notice is that as much as I'm an advocate for predictive or prescriptive analytics for changing the process, we know that it doesn't always make sense to apply this technology across all assets or across all process. Sometimes it makes perfect sense to operate an asset and break fix and not worry about spending the time to make it to predict when it might fail. This is an example. It's an excerpt from Dow Chemical, and Dow presented in a session that I was hosting at the ARC Advisory Group in 2014 on process optimization. And from Dow's point of view, they would agree, ARC would agree with Dow, and that there is no one tool for satisfying all of the needs of process or assets. So Dow would say that statistical process control and multivariate quality and online analytics and soft sensors, advanced process control, these are all things that are important to make sure that your process is optimized and you're looking after quality and uptime, etc. But it's the addition of process analytics or maintenance analytics or predictive analytics that would enhance the capabilities of those groups. So this was in 2014 when it was actually Lloyd Colgrove who did this presentation. It was a great presentation. Going forward, I think we're going to see predictive analytics or prescriptive analytics in the onset of machine learning in process. We're going to start seeing that in a lot more presentations from companies that are solving process or maintenance outcomes. And Hans, that's all I have to present today.
Thank you. I like how by the second part of your presentation, you've actually acknowledged the fact that although we're focusing a lot on assets today, it's not necessarily what is going to impact the process as such, right? And it's a challenge to bring those two together. We hope, of course, as TrendMiner, to be able to be part of that. I do have a couple more slides myself here, how we actually feel we fit in this market. So on the left of your screen, you see how much a solution is process industry integrated. On the right, you see how generic the technology as such is. When we look at what the DCS Historian MES, and we call them the full stack vendors, are delivering today from a value perspective, they're very good at DCS connectivity, data historization, and data structuring. Once you start looking into the analytics, those technologies are usually not that strong, and they'll rely on third-party technologies to help them out there. If you look at the third-party technologies that are starting to emerge into advanced analytics, you'll see a lot of generic technologies, Microsoft, IBM, SAP. They are mostly coming from business intelligence perspective. They are asset-based, modeling-based asset monitoring. We see a couple of solutions there, but bridging the gap between the process industry integration and the generic technology is usually quite expensive in time, resources, and infrastructure that is just not there today. So it usually takes a lot of time when you get such a solution to making it integrated into your plans. And you'll need extra people to do that. So at TrendMiner, we try to start from within the process industry. The founders of our company actually were people that were process engineers themselves, and said, you know what, we need to do more with this data. So we didn't really start as a company as in, well, we know a lot about analytics, let's see what we can do for the process industry. We did the other way around, and we started from within the industry itself, and then starting adding more value into the analytics. And you'll see us doing more of that on our roadmap, going more and more into a stronger analytics platform. But a lot of that is focused on the users that are currently available and working in the industry. And I've made another graph on this one to explain how these solutions usually are done. So we have our process engineer here on the right, and he has a lot of questions about the data that is hidden in his, the information that is hidden in his data in the historian. And the first thing we did, and you've actually mentioned it a couple of times, is that we hired a data scientist, right? And we asked the data scientist, well, we've got all these numbers here, time series over years and years. Um, which technologies do you know that you can apply here to find anomalies in the numbers, to find abnormal behavior? So the data scientist looks at all the technologies available, and then he started building a solution for the engineer. So that's generically what's been done today. Even if you find a solution that is already integrated into our industry, let's say, and what is it, Tableau, Click, MTAL, name them, all the ones that are out there today, those technologies still have a pretty large ramp up time before they're actually valuable for the engineer themselves. And still, every time the engineer has a new question, he has to go back to that data scientist to build him a new model. And it takes a lot of time to actually building and training those models. So that's the classic solution, how it's been done today. At TrendMiner, we wanted to take the other way around. So because we're coming from the industry ourselves, we looked at the process engineer and asking what are the tools he's actually using. And he said, and when we look at the tool the process engineer is actually using, he's using a trending client. So what we've done at TrendMiner is that we've built a new and modern trending client. And then we said, you know what, all those analytic issues that you want to build it into that's our problem. So we don't feel that in order to solve those questions for the process engineer, he should be asking those questions to yet another person who's just not there today. Because quite frankly, those thousands of data scientists you want for the process industry, I'm not seeing them. They're just not there. So we'll have to do it ourselves. So how does this look? I'm not going to go through through the application. I just used one example here of a screenshot, and you'll recognize that this is a trending client, but it is a modern version. It's not a retrofitted Windows application. It's actually built for the web. It's built to be flexible and agile. As a company, we also I like that you mentioned the quick wins and how you can instead of having those big solutions that cost years to build and maintain, it may make sense to add smaller solutions like a TrendMiner that bring value immediately. And this goes back in TrendMiner into our DNA of how we want to be different as a company. We want to bring value fast, and we want to bring that value from within the customer itself. So our tagline at the company is join innovation. Join innovation means that we as a software company, we acknowledge that we do not own the truth in ourselves. The truth is in the experience of the user and within other people within the industry. So join innovation has 6 pillars, of which half of it is customer oriented. What we want to say here is that we want to be as close as possible to the customer. We have a very transparent communication with our customers. We're bringing new releases every 2-3 months. I'm not sure our customers have seen that before from enterprise solutions. And another thing I want to focus here is that lowest barrier of communication, which is a third pillar of our customer-oriented side of joint innovation, is we want to capture as much as possible information from our customers, which means that we've even added tags, chat support in our application. So instead of starting a new support ticket on a hidden website with 78 logins, we've just built chat support within the application. We've even built feature requests within the application, so you wouldn't have to go send an email. And this is all, we want to lower that barrier. And just to make sure that we capture as much as possible of that information, we can already say that we've built new features in the technology that were requested less than 2 or 3 months before we've actually released them to the customers. So that's how we want to be fast in that innovation trajectory. On the right side, we also want to acknowledge that we have a bunch of very smart engineers, but we're only a team of 20 to 50 people, and we're not going to build the most generic technology that works for every single customer if we don't listen to other parts of the community and the open source community to learn from other technologies that have been built with thousands and thousands of people. And we also do a lot of research with long-term projects with the universities and with customers. So this is a little bit how we want to be different as a company as such. And I don't really want to take too much more time here. Is there anything you actually want to talk about as well while we are here? I'm not seeing questions popping up in the questions panel. If there are people still online that want to ask a question, please do so now. If not, we'll be happy to take your questions afterwards. You've got mine and Peter's email address here on the screen. And Peter, I definitely want to thank you for the time that you've taken for this this webinar and the chats. Oh, a simple question: will you share the video recording of this? Yes, we will, Simon. So I've recorded the session, and it should be up online in the next few days. But everyone that was in the that was here or was signed up and was not here will get an email from me with the recording. Peter, do you have any closing statements?
No, I don't, Hans. I certainly appreciate the opportunity to come and present with your community, and for those attending the session, like Hans says, my email is on the screen. If you have any questions about something that I didn't make clear in the presentation, please follow up with me, and I'd be happy to explain in further detail.
Okay. Well, if we do not have any more questions coming in right now, I thank everyone for their time, and drop us a mail or give us your feedback. Bye-bye.